I'm going to start working through the Math 137 practice problems for test number 4. I will read the problem and write down the key information. These may not be the exact same numbers as your problems, but otherwise it will be the same exact problem. So number 1 is from section 8.1. So this is probably going to be a Law of Sines problem. And they say solve the triangle ABC. And they say the angle alpha is 35 degrees. The angle gamma is 68 degrees. And side A is 16.5 degrees. And they say round to 1 decimal place. So it looks like what we're missing here is alpha goes with A, gamma goes with side C, and then we don't know angle beta and side B. So the whole key to these problems are recognition. We're given an angle, we're given a second angle and a side. So this is angle, angle, side. And when we have that, the way to solve this problem is to use Law of Sines. First thing we're going to do is, because we have 2 angles, we can automatically, very easily find the third angle. Because we know that 3 angles of a triangle have to add up to 180 degrees. So the angle we don't have is beta. So angle beta is 180 degrees minus the other 2 angles. The one angle is 35 degrees. The other angle is 68 degrees. If I did this in my head, this looks like 103 degrees. I'm going to say it's 77 degrees. On the test, you may want to use your calculator to be sure. But since I have the answers here, that is correct. Now I have to find the 2 sides, and to find the 2 sides, I'm going to use Law of Sines. Since I only know side A, I'm going to have to use sine of alpha over A, and then it's my choice whether I want to find B or C. Let's just go ahead and find B. So this is the Law of Sines that I'm going to use. And I know these 3, which just leaves me able to solve for side B. I'm just going to plug the numbers in. That's where I normally do it. Then I can move them around. Sine of alpha, sine of 35 degrees over side A, which is 16.5. Sine of beta, I just found beta to be 77 degrees. So sine of 77 degrees over side B. Easiest thing to do here is to cross multiply whenever you have 2 fractions equal to each other. A lot of people like to cross multiply. So when you do that, you get B times sine of 35 degrees equals 16.5 times sine of 77 degrees. If I want to solve for B, get B by itself, I need to subtract or divide both sides by sine of 35 degrees. So end up with 16.5 times the sine of 77 degrees over the sine of 35 degrees. On my calculator, I can do all this at once. Make sure you do your trig functions, you're in the degree mode. 77 sine divided by 35 sine equals, and then times 16.5, round it to the nearest tenth, 28.0. Then the last thing is to find side C. I'm going to use law of sines again. I can either use the alpha or the beta. I'll just go and use alpha again. So sine alpha over side A equals sine gamma over side C. If I plug in the numbers, sine 35 degrees over 16.5 and sine of 68 degrees over C. Now, if I cross multiply, I'm going to skip a step because I just did it up here. You end up with 16.5 times the sine of 68 degrees over the sine of 35 degrees. So once again, grab my calculator, sine of 68 degrees divided by sine of 35 degrees times 16.5 equals 26.7. All right, so that's problem 1. Problem 2. You write down the information. Problem 2, same thing, solve triangle ABC, round, answer. Side A, round to 1 decimal place, round your answers for alpha and beta to the nearest degree. So for the angles to the nearest degree, for the side to the nearest tenth. In this problem, they say angle gamma, 60 degrees. Side C is 18, and side B is 27. So once again, that's from the top. Even before anything else, let's recognize what we have. We have an angle and a side and a side. Now with angle side, from the top, I decide whether it's what I call matching or non-matching. In other words, this angle here is one of the sides, the side across from gamma. Well, gamma gets paired up with, gamma is the angle across from side C. So they're both here, so I call this matching, which means I'm going to use law of sines. I'm able to use law of sines for this. Now, just so you know, with angle side, that's when you got the 3 possible answers. You can have no angle, you can have one triangle, you have no triangles, 1 triangle, or 2 triangles. And we're not going to know until we start crunching the numbers to see what we have. So let's apply the law of sines. So I can say sine of gamma over C. Since I'm given side B, that's going to allow me to write an equation with sine beta over B. I know these 3 values, so I'm going to be able to calculate eventually angle beta. Let's just plug in the numbers. Sine 60 degrees over side C, which is 18. Sine of beta, I don't know that, so I'm going to hopefully solve for beta over side B, which is 27. And what I'm going to do here, just to make it simple, I'm not really going to cross multiply. What I can do is just, if I multiply both sides by 27, then I end up with sine of beta is 27 times the sine of 60 degrees over 18. So I'm going to go and do this calculation, and then what I'll have to do is I'll eventually have to take the inverse sine. So let's go and do this calculation first. So 60 degrees, the sine, make sure your calculator is in the degree mode. times 27 divided by 18. Now, even though, so I'm not gonna round quite yet. You never want to round off in the middle of the problem. I'm going to keep like 3 decimal places. If you start rounding off in the middle of the problem, a lot of times you end up with the wrong answer because you lose some of your significant figures. So I'm going to go ahead and leave some extra digits here. So just in case, when you have this, if we want to solve for beta, you take the inverse sine of both sides. Let me give myself some room. If I take the inverse sine of both sides, because I want to actually solve for beta. Right now, the beta is inside the sine. The way I sort of get rid of the sine, or the way I free up the beta, is I take the inverse sine. Because the inverse sine of the sine, these things cancel out and you're left with beta. Of course, I have to take the inverse sine of both sides. So now in my calculator, I have 1.299. Now I'm going to take the inverse sine. So on your calculator, that little, look for the key with the sign with a little -1 subscript or superscript. And here's what my calculator says. Error. Now this might actually be the correct answer. If in fact this is an error, that means I have a situation where I have no triangles. It's not possible to create a triangle with these 3 conditions. However, you have to be careful you didn't make a math error. Sometimes if you're not careful with your math and you make a math error, then you can get this answer not because it's truly the answer, just because you made a math error. So let me go back and just double check and make sure I didn't make any math errors. And if I'm pretty sure I did the math correctly, then I'm going to say this is a no triangle answer. So once again, I'm given the angle gamma and C, and these go together, and then side B. So I can use the law of sines here, and I'm going to eventually solve for beta. So sine of 60 over 18, which is C, sine of beta over B, which is 27. Multiply both sides by 27. And I'm going to go on my calculator. I'm going to do this calculation again, just to be sure. So 60 degrees, I'm in the degree mode of my calculator. I hit sine. I'm going to take that times 27 and then divide all that by 18. And I get 1.299. And the last step is now I'm going to take the inverse sine of 1.299. And actually this makes sense because you know what? If you think about it, for this inverse sine function to work, this number has to be between -1 and 1. Some of you may not realize that, but I can already tell right now that this is not possible. But if I want to confirm it, I can go in my calculator and take the inverse sine and you get error. So I'm going to say no triangle. And then I think on the answers, they have like 3 empty blanks. And what they have you do is basically, they just have you type in no solution for all 3. And that is actually correct. Number 2 is actually no solution. In other words, you cannot create a triangle with these conditions. It's not possible. Probably one of the sides is too short or the angles are off. All right. Continuing on. Number 3. Another one, solve triangle ABC. Now they give me alpha is 43.15 degree. A is 5.03 and B is 6.15. Now they say round your answers to 2 decimal places. So both sides and angles have to be two places. So once again, what do we have here? Have an angle, a side, and a side. So angle, side, side. And now I want to see whether it's matching or non-matching. So my angle's alpha. One of my sides is A. A and alpha go together. So once again, this is matching. So now I'm going to use law of sines to see what I have. And once again, I could have no triangle, one triangle, or two triangles. So applying the law of sines, sine of alpha over A, since I'm given side B, sine of beta over B. Let's go and fill the numbers in. So sine 43.15 degrees over A, which is 5.03. And then sine of beta over 6.15. So this is exactly the same as problem number 2 in terms of solving it. So I'm going to have sine of beta is 6.15 times sine 43.15 degrees over 5.03. So I'm going to grab my calculator. 43.15 degrees, the sine, times 6.15 divided by 5.03. I'm going to keep maybe 4 digits, 8362. Now I know since this is less than 1, I'm going to actually have an angle here. So beta is going to be the inverse sine of 0.8362. So on my calculator, inverse sine, make sure I'm in the degree mode. And since they want to 2 digits, 56.74 degrees. Now I'm going to check real quick the answer because I don't want to keep working if I made a mistake. And I believe that is correct. So now here's the tricky part. As of this point, I know I have at least 1 triangle. I might have 2. What I do is I'm going to go ahead and finish out this first triangle. And I'm going to go ahead and maybe I'll put a star beside this because this is the angle I'm going to have to use again when I start looking for the second triangle. But for now, if I look up here, what I really have to figure out, I have to find angle beta, I have to find angle gamma, and I need to find side C. So far, I've got angle beta. If I've got angle alpha and beta, I can find angle gamma by just taking 180 degrees minus alpha, 43.15 degrees, minus beta, 56.74 degrees. And with these decimals, I am for sure going to use my calculator. 180 minus 43.15 minus 56.71, 80.14 degree. Now here's what I don't like. I just checked the answer and they said 80.11. And that's actually, on the test, I would give you full credit because that's not actually, when I look at the answer, when I add alpha which is 43.15. So I'm looking at, I have access to the answers of WebAssign. I'm going to add their three angles together. And then beta is 56.74. And they say gamma is 80.11. $43.15. I wrote, oh, you know what I did? My mistake. This is a 4 here. Maybe you guys knew that. My apologies, WebAssign. That was my mistake. 180 minus 43.15 minus 56.74. So I do get the same answer as WebAssign. That makes me feel better. So now for this first triangle, once again, I can even write it over here, first triangle. There may only be one triangle, I don't know, but I know for sure there's at least one. The last thing left is C. I'm going to use law of sines to figure out C, and I can use law of sines with either A or B. I'll just do A. So I'm going to say sine of alpha over A equals sine of gamma over C. I know these three things. So sine of alpha, sine of 43.15 degrees, and A is 5.03. Sine of gamma, gamma, I figured out just now it's 80.11 over C. Cross multiply. I'm going to skip a step just to save time. End up with C equals 5.03 times sine of 80.11 degree over sine of 43.15 degree. I need to be careful because my writing keeps messing me up. So sine of 80.11 divided by the sine of 43.15 times 5.03, two decimal places, I believe it's 7.24. Although, well, let's see, it's 7.245. So here, once again, WebAssign, because theoretically, I got to see, should this be a 4 or a 5? You go to the next digit, it's a 5. Normally, since you have another digit, you go one more digit, and since it's 5-4, I guess that is above halfway. So it should just be 7.25. I guess if it's 5, you round up, correct? So 7.25 would be side C. Now I have to see if there's a second triangle. So here's the first triangle, angle beta, angle gamma, and side C. There might be a second triangle. Now here is how you check for the second triangle, maybe a little tricky. The very first thing I did for the first triangle was I found angle beta, and that was my only choice. That's all I was able to do. And you noticed I put the star here now. The reason I put the star here now is because now I'm going to take this beta. What's going to happen is if there's a second triangle, there's going to be a different, in other words, these three are going to stay the same. What's going to change is if there's a second triangle, there's going to be a different angle beta, a different angle gamma, and a different side C. The three they give you will be the same for both triangles. It's the three that we have to figure out are going to change. So here's what I know. When I found the beta for the first triangle, when I go look at my second triangle, I'm going to call the new beta. I put like this little tick mark at the top. So that indicates this is the second angle beta. And the way we calculate the second angle beta is we take 180 degrees and we subtract the first beta angle. And I don't have time to explain why you do this, but this is just the way you do it. The very first angle you find for the first triangle, you subtract it from 180, and that's the second possible triangle. So I take 180 minus 56.74. So if there is a second triangle, this is going to be the beta angle. Now at this point, I don't know if there is or not. The next step will tell me whether there is or is not a second triangle. Now the next step is, because I know alpha doesn't change, matter of fact, I'll write here the stuff from the original problem, because these three are not going to change. So I know alpha is 43.5. I know that my possible second beta is this. So let's go find the second possible gamma. So you take 180 degrees minus alpha angle minus my new beta angle, right? Alpha is this and beta is this. So minus 43.15 degrees minus 123.26 degree. So if I grab my calculator, this will tell me what I've got going on. So 180 minus 43.15 minus 123.26. And I have 13.59 degrees. Now here's the deal. If this second gamma angle is a positive number, then we do have a second triangle. Matter of fact, here's the second value of the gamma. If there is not a second triangle, what will happen is this will end up being a negative angle. And of course, for these triangles, we're not going to have any negative angles. So for some reason, if this is a negative angle here, then I'm done, and it's only one triangle. But for this problem, since it's positive, there is a second triangle. So here's the new beta, here's the new gamma. The last thing I have to find is the new side C. I'm going to use law of sines. I will use the alpha, so sine alpha over A is sine my new gamma over my new side C. So sine of alpha is sine of 43.15 degrees over A 5.03. Just so you know, I could have used beta and B for the law of sines. Of course, make sure you use this beta angle and your B here. I just chose to use alpha and A. You'll get the same answer whichever one you use. So the sine of my new gamma, 13.59 degrees over my new C. So if I do cross multiplication, I get 5.03 times the sine of 13.59 degrees over the sine of 43.15 degrees. If I do this calculation, it should give me the new side C. Sine of 43.15 times 5.03, 1.73. Now what they do is just so you know, now if I see all this work on your scratch paper, you'll get full credit. But on the answer, the first triangle, they say smaller c. So you compare your two c's. This c is 7.25. This c is 1.73. So when you fill in the information for the first triangle, they want you to fill in this one first because they're saying start with the smaller c. And then you would fill in this triangle second. All right, so it's interesting how problem 2, you recall back, problem 2 was an angle side-side matching. We used law of sines. We found out we got this error because it's not a triangle. Then problem 3 was another angle side-side matching. Turns out we have 2 separate triangles that have these same conditions. So now let's see what's going on with problem 4. Let me look at the problem. Another solve angle ABC. They give me angle beta, 67.596. I don't know what the deal is with all these decimal places. Side B, 0.623, and side C, 0.404. So all the answers are going to be the 3 decimal places. And basically, what's left here? Well, let's look. I have angle, side, side. And I have angle beta and side B, so this is the matching. So once again, I'm going to use law of sines, and I can either have no triangle, 1 triangle, or 2 triangle. So what I'm going to have to find is, I'm going to have to find, in this case, angle alpha, angle gamma, and side A. So law of sines, sine of beta over B, I can find sine of gamma because they've given me side C. So I know these 3 things here, which is going to allow me to solve for angle gamma. So the sine of beta, sine of 67.596 over B, 0.623, sine of gamma, I don't know it, I'm trying to solve for gamma, over side C, 0.404. So now sine of gamma is going to be 0.404 times the sine of 67.596 degrees over 0.623. Grab my calculator, make sure I enter the numbers all correctly. The sine of 67.596 divided by 0.623 times 0.404. So I'm going to put 4 digits down just to be safe. 995. So I think, well, let's not round off yet. Let's go and take the inverse sine of this. So gamma is going to be the inverse sine of 0.5995. So gamma, 36.836 degrees. And that's actually correct. So once again, in this case, the first angle you find when I get ready to check for my second triangle, this is my starting place. So I'm going to, of course, box it, put the star by it, because I will need to use this number again. Let's go and finish out this first triangle. So now, let me go ahead and I can find angle alpha, because angle alpha should be 180 degrees minus angle beta minus angle gamma. So 180 degrees minus beta, which is 67.596 degrees, minus gamma, which is 36.836 degrees. I don't know why they give you the 3 decimal places. 180 minus 67.596 minus 36.836, 75.568. So now I know the 3 angles. The only thing I have to figure out is side A. I'm using law of sines. I can either use law of sines with beta or gamma. It doesn't matter. I'll just do beta. So law of sines, sine beta over side B, sine alpha over side A. I know these 3 things. Sine of beta, beta is 67.596 over B, which is 0.623, equals the sine of alpha. I just found alpha to be 75.568 degrees over A. I cross multiply and solve for A. A is going to be 0.623 times the sine of 75.568 degrees over the sine 67.596 degrees. So hopefully, grab your calculator, enter all these digits correctly, divided by the sine of 67.596, and all that times 0.623, 0.6525 or 0.653 side A, and that is correct. Now, so this is the first triangle. Is there a second triangle? We have to check because we don't know until we see. For this problem, the starting point is the first angle I found, which is gamma. That's why I started. So what's going to happen is, once again, the 3 things they've given me from the start are not going to change. So beta is going to be 67.596. So these 3 things I'm just copying down. Side B is going to be 0.623. Side C is going to be 0.404. If there's a second triangle, I'm going to have a different alpha angle, a different gamma angle, and a different side A. So the place you start is the very first angle we found for the first triangle. You start, and we're going to find a new gamma, and it's going to be 180 degrees minus the original gamma, 36.836 degrees. So if we have a second triangle, this is going to be the new gamma angle, 36.836, 143.164 degree. Now, The next step will tell us whether we in fact do have a second triangle. So now that I know beta, I found the new gamma. Let's calculate the new alpha angle. So once again, the new alpha is going to be 180 degrees minus the original beta angle minus my new gamma angle. So 180 degrees minus beta, 67.596 degrees, minus my new beta, 143.164 degrees. So the new alpha is 180 minus 67.596 minus 143.164. I look at the angle, negative 30.76. All right, well, when you have a triangle, you can't have a negative angle as part of a triangle. So therefore, what do we say? All this work was looking for the second triangle. There actually is not a second triangle. All right. So I think problem 5, I think is going to be a law of cosine problem. So let me stop here and give my voice a break. And the next video I start will be starting with problem number 5.